I'm really excited about the first talk of today. I think it's going to be really cool. I'm just thinking about Kuhlmann. Sorry. This is Brooke Kuhlmann. And I wasn't trying to do that. I have thought that in my head many times. Cool, man. Cool, man. Sorry. I'm sorry, Brooke. You probably gotten that your entire life.
Yes. Now I got to live up to this reputation.
Well, I think so. I think you already have. Brooke has one of the coolest jobs that a Rubyist can have. I feel like any job in Ruby is cool. Most of us are Rails developers. That is what it is. Brooke is a Hanami developer, which is pretty awesome. And also, he's working in hardware adjacent land. So the combination of the two things, like building in Ruby with Hanami and working with hardware, pretty awesome. So I'm really excited. Brooke's been around for a long time. He's done a lot of consulting, tons of open source, and working now with Terminal. I think he's going to have a lot of interesting things to share, and seeing the both what he's built and these e-ink devices, or e-paper, I guess that's what it's, e-paper devices, I think it's going to be really cool, and people will be interested. I keep saying cool, I'm sorry. Brooke, thank you so much, and everyone, if you can give him a hand. Thanks.
Yeah, hey everyone, thanks, and thanks Jeremy. Also, before I get started, I just want to give a huge shout out to Thomas Cannon, Christine Seaman, and also John Sully for this whole rigmarole that I'm going through to get this display to go through airport through Christine's machine. So we're pulling this off. So this entire talk is also completely live, running live. It's rendered live through Terminus, the Hanami stack that I'm going to be demoing here. And I'm running all the slides through there. And then the devices that you have out in the audience, just keep passing those around. Talk to Thomas and Christine. Keep passing them around, because as I go through these slides, those are going to update in real time. And we're going to actually deconstruct on how that's happening. So just to give you some setup here, right? Terminus, if you don't know, is actually an open source project by the company called Terminal. And that's what these e-paper devices are that are going around in the audience. And it's short for, we call it BYOS, but it's build your own server. And the specifications are all handled by me and all the open source stuff related to this. But Terminus is the flagship implementation of the BYOS setup that we have. It's also private and secure by default. So what's really cool about this is you get your devices, you put them on your own private network, you take Terminus, you set it up on your Raspberry Pi, NAS, whatever. And then all that data is yours. It's all private, so you can render anything that you want on there. And then finally, like Jeremy was saying, it's 100% open source. I'm an open source developer. I've been doing this for more than 20 years. And I just love being able to give back. I love being able to take my open source projects to the client work that I go to, because I don't like having to repeat myself and solve the same problems twice. And then that's all folded into Terminus as well. And again, this is all open source, so you can download it, use it, and actually level up as well. Now, there's a lot of APIs that Terminus support, but the main thing I want to point out today, just so you get a sense of what's going on with these devices and how these slides are working. And also, this is just a little retro, because I'm actually rendering these as 2-bit images with 4-gray scaling. So that's why it's a little retro with the slides here, because they need to be able to render on the devices. But the way it works is, the devices, they wake up and they say, hey, Terminus, what's the next item in my playlist? And Terminus is like, here's the image, sends it down to the device. The device says, thanks, I'll render that, and immediately go to sleep. And then it wakes up at a certain interval to get the next image. And so for the purposes of this demonstration, I've set them all at 1 second refresh. So that's why they're kind of flashing and going through as I go through the slides. You wouldn't normally do that, because it's going to drain the battery pretty well, but it's fun for presentation purposes. The nice thing about this is, because they're kind of dumb terminals then, is that you can just, anything you dream up, right? If it's personal finances, stock stuff, personal photos, that's all yours. It's just rendered on the device, on your network. It's a completely closed circuit. So let's talk about the architecture a little bit, now that you got kind of the premise of what I'm talking about here. And the architecture, it basically consists of this. But for the purposes of this demonstration, or for this talk, I want to focus specifically on Hanami, htmx, and CSS, especially view transitions. I just want to expose some really advanced things that you might not be aware of, and you could really enjoy. You'll get to see it through Hanami, but you'll also be able to take it with you and use in your own applications. So first up is Hanami. I would love to give multiple presentations just on Hanami alone. I could talk your ear off. There is so much to talk about. I can't do that here. But I am going to give you a high-level overview, which is basically repositories, which is the persistence layer, actions, which is dealing with request response, and then the view layer, which you're pretty used to, which is like, templates, partials, presenters, and so forth. If you squint at this, really this is the MVC pattern, but it's a little different than what you're used to. The model layer is really the structs, they're whole value objects in Hanami. Those come back as read-only objects from the database, which is really, really a fresh of breath air, because with Active Record you get the whole kitchen sink, and there's a whole bunch of nonsense that happens with this, but these are just whole value objects. Actions are not the typical like controller where you have all, create, update, delete, new, edit, and so forth. In Hanami, you break them down by each one of those. You have an object for each one of those, which is also really nice in terms of design. It also encourages really good encapsulation in object-oriented design. And then finally, the view layer, which is, again, your templates, your partials, your presenters, and so forth. And we're going to get into the last two here in this presentation. So in terms of implementation, then, I thought it would be really fun to actually break down what you're seeing here, how all this is working. So let me actually pop out so that you know that this is not bells and whistles, because as I go through these slides here, this is running in Terminus, like I said. And we're going to break down how this is working. So I'll pop back in here, and hang on just a sec. I wasn't ready for holding my mic at the same time. There we go. So we'll get back to resolution that you need. So the purpose of this talk is actually break down this implementation, just basically deconstruct what I am giving the presentation on so that you can actually learn on some of the design patterns that are being used in this. So from a high level, we're going to focus on the viewport. That's the slide that you see currently. And then the progress bar. Now the progress bar you saw when I popped out, but in full screen mode that drops off because you just want to focus on the display. And then finally the action section, being able to go backwards, forwards, being able to see what slide you're on out of like 92 in this case. Actually it's 95, I had to edit it after. But from a high level overview, what we're going to tackle here is we're going to dive into Hanami, we're going to talk about htmx, we're going to talk about CSS view transitions, and then we're just going to wrap this up at the end with a little bit of JavaScript. So again, at the high level, we're going to talk about routes, and only going to spend a little time here briefly just to kind of set the stage where in order to render these slides, we're going to have an index, and then we're going to have a show view. And the show view is actually going to do the main work here, which is always getting a new screen and then rendering that screen. The one thing I want to point out before I move on from routes, though, is that you see this dot notation. This is dependency injection, but I'm not going to talk about this here. We're going to come back to it in just a moment, but I want to keep this syntax you see in the back of your mind because we're going to come back to it. So in order to kind of show this off, there's really two actions, again, that I want to work with, which is the index action and the show action. I'm going to use the index action to actually give you a sense of how the design and infrastructure works within Hanami, and then we're going to focus on the actual implementation, the code itself, in the show action. So to kick this all off, the show action looks like this. I know it's small, but it fits all on one screen. The thing that I want you to take away with here is there's not a lot of code in order to pull this off in Hanami. Now, if we zoom in, what I want to focus on is these two include statements up here. And if we blow that up, that's what this looks like now that you can kind of see it in a little bit larger, which is I've got three dependencies coming in. I've got my repository to get the data. I've got my view. And then I've got a slide window here. It's a constant that I'm just going to bring in, and I'm going to new up here in a little bit. And what that expands to, that little bit of syntax that you saw there, that actually expands to what is known as the bare words pattern, which is basically it's just setting up the initializer dynamically. This is happening dynamically through those two lines that you saw. It's injecting those dependencies, immediately setting those as instance variables, and then making them a private attribute reader. Didn't make sure to keep my top of the bottle unlocked there. So hang on a sec. Sorry about that. So in the bare words pattern here, you have your dependencies being injected, and like I said, it sets up the instance variables, and then immediately makes it private through the attribute reader. And the reason this is important, because in object-oriented design, you always want your objects to be highly encapsulated, and you want to make them as much as private by default, because you only want to expose what you need. You don't want it to be an open sieve and expose everything. So that's what's happening here in that code that you saw on those previous 2 lines. And what this boils down to is that's 2 lines of code that I'm writing versus 11 lines of code. And you might think, well, that's kind of a cool savings, but that's just one action. Well, if you take it across all the objects in your application, especially in Hanami, because this is a very common pattern, you end up with 11 lines times however many objects in your system. That's a lot of code that you are not writing and you do not have to deal with. So this is a really big savings. Now, ultimately, what this boils down to is this is the D in solid design, the solid pattern, which is dependency inversion. And in order to explain this, I want to take just a moment to actually look at 3 gems that I maintain in open source. One of them is containable. We're going to talk about that because I want to break down the patterns here. And also, the documentation here I think is really good too. If you want to dive into this and learn more, you can actually understand through the documentation, through the examples, and play with the code themselves, so you can actually learn this a little bit later better if you want, and you can inject it into your own applications. So at a high level, containable, what it's doing is it's taken a module called container in this case, and then you extend it with containable. And that adds in the behavior so that you can have namespaces and a registry to register your dependencies that you want to inject. The key thing here at the very top level, and again, normally when you create a container, you're going to have a lot of dependencies, but I'm shrinking this down for presentation purposes because we're only dealing with 2, but normally you'd have more. And you would set up your namespaces. In this case, I have a namespace for repository, and then I have my views. And then later, I go down and I register those dependencies. Now, here's the key thing. Like Afet was talking about yesterday, there's a whole lot of lambdas and procs throughout Hanami, and this is one of them where we're using blocks to actually encapsulate the dependencies that we want to new up, but they're not initialized yet. This is really key, because in Hanami, it wants to boot as fast as possible with the lowest memory possible. And so these dependencies are being registered, but until they're injected, they're not initialized. It's a key thing here, and that's why when you take dependency injection and you move it to, and you use containers to manage your dependencies, I forgot to do the time check on my, anyway, make sure that I'm not running too long here. But when you set that up, you're able to inject those, and then at a time of injection, they'll get initialized, which saves you, it saves you from creating those objects, multiple objects, until you actually need them. So if you collapse this down a little bit more, and I shave off what those blocks are doing, here's that dot notation I was showing you through the routes. That's how you reference them. Those namespaces actually is just repository.playlist and then views.playlist.screens.show. That's how you're able to get that dependency and then inject it later. That's how that syntax all comes together that I was showing you earlier. So once you have your container and you have all your dependencies registered, now you want to take it to the next level with dependency injection. You want to introduce something called infusible. The concept's same it's not used in Hanami, but the concept's the same, which is you require infusible, and then you take that container that we just defined in the previous screen, and we inject it in, and then it's assigned to a concept called deps. And what's really nice about this is once you have the deps, then you can say from your container, I just want the repository and view, those 2 dependencies, I want those injected into the action, the index action I just showed you in those previous slides. That's what I want injected. So what's beautiful about this is you have your container, you have multiple dependencies all set up, but then at the time of injection for your objects that need them, you only tell Infusible, hey, just these dependencies, that's what I want injected from that particular container. Super powerful. And then the last one is initable. And initable is just a nice way when you don't want to use a container, you don't want to register your dependencies. In this case, I just have a constant that I want to inject. I don't need all that setup. So initable just makes it really nice so that you don't have to build your initializer. It just does that dynamically and injects the dependency in this case, which is slide window. And again, that just blows out to the bare words pattern. Again, nothing magical there. It's just setting up my constructor. I don't have to write all that code myself. So when you put all this together, what I'm really talking about is the module builder pattern. It's a more advanced pattern in Ruby. There's documentation. I wish I could do an entire presentation on this alone. It's really fun to talk about, but you'll have to dive deeper later if you want to get into this more. But that's what these 3 gems are adhering to. They're using the module builder pattern to pull off that nice syntax that you've been seeing. So now that we've kind of talked at the high level on those two lines of code, let's actually move a little faster here and talk about params. And the way this works is, this is through the dry RB ecosystem. So it's using dry schema and dry validation to set up basically how to validate your parameters that are coming in. So what you're probably used to is like strong parameters. But this is actually way, way more advanced and much, much nicer because you can actually define this once and then reuse all over your application. And the way this works is this one powerful line here is you're sending up params, and you're in the block here, you're saying, hey, I'm going to require that the playlist ID, that's the key that's coming in, I want it to be filled, and I want the value to be an integer. And if that all passes, it'll do the conversion into an integer. So if it was a string, but it can get turned into an integer, a dry validations and dry schema will do that for you. So this line of code is extremely powerful and just how succinct it is and what it's actually doing for you. So once those, the validation is handled, then you can go into the handle method. Now, the key thing to take away here in Hanami is that the superclass action is actually adhering to the command pattern, which has a call method on it. And the really nice thing about this is actions, if you think about it, they're also like small pieces of middleware. So if you've ever done middleware, built middleware in your apps, you know that as long as you implement the call method, now you've got a piece of middleware, right, to handle the request response. That's exactly what actions are in Hanami. But you don't see the call method here because Hanami is saying, hey, in the superclass, I'm going to handle all that for you. I'm going to take the request response, I'm going to build up those objects, and I'm going to pass it down to a method called handle, which you're going to implement. This is also known as the hook method pattern. Because the superclass is saying, hey, I won't implement this, I expect the subclass to do this, and I'll hand it off to you to do the implementation details. So what's nice here then is I've got that request response object coming in. I say, hey, if those parameters are not valid, I'm going to do a halt. I'm going to send back a 422 because I can't process that. And then lastly, I'm going to load up my view window, and I'm basically going to compute what the before screen is, the current screen that you see now, and the next screen that's going to be coming. And then lastly, I'm going to take all that, and I'm going to send that down as keyword arguments to the view so that it can get rendered. So now that you understand how that works, let's actually look at the show action really quick and then get into the view layer. So again, I can't fit this all on one screen. It's not that much code, but we're just going to kind of break it down so you can see it at a nicer resolution. So I'm going to subclass from action. I'm going to inject my dependencies. We've already talked about that, so nothing special or new there. Same thing with parameters. I'm going to set my parameters, but it's a nested RESTful resource, right? So I need my playlist ID and then the ID of the screen that's coming in. Then I'm going to handle that request here. The one thing is I've got a couple of private methods that's going to resolve the attributes that are going to be passed down to the view. And that's done here through this private method of update current item. All this is really doing is that in Terminus, in the playlist here, you can control it automatically or manually. So I have the playlist set up so that when it's manual, every time I hit my back and left arrow keys to go through these slides, it's moving the current item in the playlist. However, if it was set as automatic, every time those devices in the audience, they wake up and they say, hey, what's my next thing? It'll advance to the next item. But I don't want to do that in this case because I want all those devices showing the same screen at once, so I need to control it. So that's what's happening here. And then in the privates, the last private here method is basically building up the view settings. And all I'm doing is building up that hash that I'm going to send as keyword arguments down to the view layer, which is my playlist, my before and after screen, the current screen, and then the layout. Here's where you're getting the first taste of htmx. Because in the htmx gem that I maintain, and I'll get to this in a moment, it actually has some nice syntax because it can determine in the request that's coming in, htmx sends HTTP headers through the request to say that, hey, it's an HTMX request. This is powerful because with HTMX, you want to send partial information over the wire and slip that into your DOM to render. Well, if it's a normal web request, you want to render the entire layout and everything to load the screen because you want your back history buttons and everything to work in your browser properly. But if it's an HTMX request, you want to strip off that layout and just get the raw DOM partial to slip into your DOM to update it. And so you want to detect that. And so what I'm saying is, hey, if it's an HTMX request, I want to tell Hanami to turn the layout off because I want to render even less information. So now that you've got those two actions under your belt, let's actually jump into the show view. So the view layer in Hanami, allows you to basically define what it is that you're going to expose from your action. This is really important, by the way, because in other frameworks, you might set up an instance variable, and then that damn instance variable will just perpetuate all the way down through the view, to the template, to the partial, and you can get yourself into a lot of trouble. We all know that on some frameworks that love to do that. So in the view layer here, what you do is you say, hey, look, I'm sending those that keyword arguments that you saw from the action down into my view, but once it gets to the view, I have to explicitly expose what I want to send to my template, and that's what this expose logic is doing. So at the top, I'm injecting my dependencies again. Here's a little bit more dependency injection. I'm going to expose my playlist in my current screen, and then I'm doing some calculations. We can do dynamic calculations, again, using blocks. Very powerful in Hanami, where I expose like the index and the total. I'm doing calculations. That gets calculated once and then cached in the view. It doesn't get called multiple times every time I render it in the view once I've computed this. So again, some really nice things happening here in Hanami. And then finally, and again, I'm not showing you everything. Again, it's not a lot of code. I'm just collapsing some of this down because I want to focus on the concepts for you, not so much every single detail. But lastly, you can also have private exposures because I just want those just to the view so I can aid in the public exposures to be able to render the information I want in my templates. So that's what's happening there with that syntax. So now this leads us into templates and partials and a little bit more htmx. So now we're in our template, right? And we're passing all those keyword arguments down. So they've been exposed, they're active to the template, but the template then has to pass those down to the partial. So I know that this is a little bit more information than I normally render in my templates, but it's just because I'm doing some calculations for URLs, because I got to calculate first, last URL, previous and next, and so forth. So here's where htmx comes in. So this gem that I maintain, open source as well, is used heavily in Hanami here. In order to render this information both on the action side and the view side. And so the first thing I'm going to do here is I'm going to set up the section. I'm using semantic HTML here. And you'll see that I've got some HTMX syntax in here. And what that really boils down to is it's just syntactic sugar. I'm using the htmx gem to basically not have to type hx every time. And I also don't want to type strings for my keys every time. I just want to use symbols. So htmx just allows you to have that nice syntax of just having the keyword value there, and then it'll splat it out as keyword arguments into the tag in this case. This is just going to render an HTML section tag. Now, the other key thing I want to point out here too in htmx is normally when htmx makes an HTTP request, it's going to take that request and immediately swap out the current element that it's defined on, where you see htmx defined on this tag section element. It's going to swap it out with that data. Now, in this case, what I want to do is I'm using a select out of bounds. So select OOB is out of bounds select, and I'm going to select 3 elements from that partial that's coming down. I want the slide, I want the progress bar, and I want the actions where all the links are. I'm just going to pull those out instead. And the last thing I'm going to do is I'm going to say swap transition true, because HTMX has CSS transition support built in by default, and I just want those silky smooth slide transitions to be turned on, and HTMX allows me to do that. So here's the viewport. What you see this slide right here, that's the viewport element, right? It's just a div that wraps that image. Nothing special going on there, but that ID is critical, right? Because that's the out-of-bounds select that I'm using. Then I'm selecting the progress bar because I want to pluck that in. And then I also want to have my action sections where I have all those links. You know, the previous link, the last link, the first link, and so forth. Now, there's a partial here that I'm using called direction. We're going to get to that in just a moment. But the stuff that I'm passing down is I'm creating that partial because I want to dry this code up. Every time I render these links, I don't want to keep typing out all this URL information. I just want to send it out to a partial to render it. So that's what's happening here. But the key thing to take away is that I'm sending down the URL that I need to go to. And then I'm telling the direction to be backwards or forwards. This is going to break down into a data attribute on the HTML element itself, and we're going to use this later in the final slide. And then we can also tell HTMX to use keyword shortcuts. So basically, arrow left and arrow right is how I'm moving through these slides. And then finally, we show the status, number of slides that we're currently on, and then direction for the next link. So same thing, but in reverse, like you saw up top. And here's that partial that I was getting at. The real key thing here is that I'm using that to dry up the code, but the trigger in htmx, the syntax for this is normally it's just a click. Every time you click on a hyperlink, it's going to kick off the htmx event. But I'm also saying, hey, not only should a click work, but when I do a key up on that arrow key left or arrow key right, I want that to fire the link as well. So some nice syntactic sugar there from htmx. Now this leads us into the next part, which really makes this all sing and come together, which is CSS. And I'm leaning on modern browser technology because there's so much we can do in CSS today, where all this slide transition stuff, all this silky smooth stuff used to be a crap ton of JavaScript. It's all native in the browser now. So let's actually take a look at that. And this is happening through view transitions. And with view transitions, it's built upon animations. We've had that in CSS for a very long time. But what I'm doing here is I'm saying, when I go backwards, I'm going to slide out. I'm going to slide out to the left in order to go forwards, right? And that transition is going to just move that slide from 0 to a negative 100. And if I'm going the other way, it's going to move it from 100 or from 0 to 100% off screen. So it's trickery, but that's how the animations are happening to move those slides around. But the key thing is, once those animations are defined, just like you saw on that slide there, now you can use view transitions. And the key thing I wanted to highlight here is view transitions allows you to style the groups for the new transition and the old transition, which you see below. But the key thing is I'm turning on overflow hidden because all three slides are actually visible here, but I'm hiding the left and the right, the previous and next, because I just want you to focus on the current. If I didn't have that there, you'd be seeing all three slides. Then we want to define how the new transition is going to work and how the old transition is going to work for depending on which direction you're going. So all this is doing is picking up those animations I showed you in the previous screen and being able to slide in from the right, going that direction, or slide in from the left to go that direction. That's how that's how view transitions are kicking this into gear. And then the final piece is just to wrap those in CSS classes, which we can slap on at the last minute that we're doing the transitions, so we can teach view transitions and tell it which direction to animate, which direction are we going to animate. So I wrap those by the view transition name into a CSS class, and then that's how we'll kick it into gear. So this brings us to the last piece, which is just a tiny bit of JavaScript to pull this all together, which is basically tapping into htmx events. htmx gives us hooks in which to tap in. And so the key thing here is before the transition occurs, I want to tap into htmx and I want to say, hey, you know those two classes that we've been setting? I want to clear those because I don't know which direction I'm going just yet. I just want to get rid of those. And then the data, the HTML data attribute that I was showing you before, it's either backwards or forwards. I'm just going to say, hey, if it's forwards, slap on slide left. If it's backwards, slap on slide right. And that happens just before the view transition, and then that kicks these silky smooth transitions coming in together. That's all that's necessary to make that come together. So, in summary, we've got to see a little bit, and again, I know it was compact, I had to go fast. There's a lot of things to explain here, but I wanted you to get a taste of how this is all coming together, and you've seen that through Terminus, the live devices rendering locally. You've got to see a little bit of a taste of Hanami, the power of htmx, because I'm not writing a lot of code, I'm sticking to the DOM as close as possible using native HTML. And then CSS, and I'm stripping out a whole ton of JavaScript because I can use the power of modern browsers and stick to view transitions. And you also got to see design patterns, right, that are used in this app. And there's a lot that's in the Terminus stack, but also in the Hanami stack. And in this age of slopware and kind of the race to the bottom common denominator, I'm not saying that these tools are not valuable and you should use them, but do not check your brain out. Make sure that you're adhering to these well-written patterns and in the community for years from other engineers, from greater engineers. We should not lose focus of that. We should still be able to apply that to our code, and this is one example of being able to do that. So thanks so much. Really happy to share this with you. Please let's connect. Here's the QR codes if you want to get access to the source code for Terminus. The slides are all available online. You can get it there. And as a final form of gratitude, you can use Blue Ridge 20 to get $20 off any device of these terminal devices that have been floating around in the audience. I've been showing you how this is all working. It's only good for 1 week, but please feel free to use that. And lastly, just an ask for all of you that if you enjoy this, if you have like a business need or anything that you would like to use like Terminus on-premise or be able to use in your offices with your team, do really creative things, please reach out to me. I would really love to talk to you more and work with you in that aspect. So anyway, thanks again. Thanks to Christine and to Thomas and to John for helping me put all this together, trying to run all this live and all the technical details that went in, or difficulties that went into that. So thanks again.